Another scenario is you've got a piece of equipment that has lots of data, sensors on it about how it's performing. And what if you could go up and just ask that equipment, how are you doing? You could actually, talk to your car engine and like understand the maintenance that's required on it.
Was there a moment where you realized Edge AI specifically would have such a large impact?
So it's inevitable that this is just going to become a thing. Like, bring AI to your data. You don't want to send your data to the AI, right? So you want to run AI workloads as close to where the data is created as possible. It's not edge versus cloud. It really is edge plus cloud. The other benefit of Edge AI is the lower cost.
What's the biggest Edge AI myth that you feel like needs to die?
That it's too complicated. You'd probably be surprised at how capable it is and what it can do.
Hey everyone, we're back today with another episode of the Chief AI Officer Show. And today I'm speaking with Pete Bernard, who is the CEO at Edge AI Foundation. Pete, thanks so much for joining me today.
Yeah, Ben, nice to be here. Appreciate the opportunity.
Looking forward to getting into all things Edge AI and what you're doing at the foundation. Before we get started, can you give a brief intro to who you are, your background, and Edge AI Foundation?
Sure. Well, I'm based here in the Pacific Northwest. I mentioned earlier in Bellevue, Washington. Originally from New Jersey, Northeast New Jersey, but spent about 14 years in the Bay Area, Silicon Valley, doing kind of startups and small tech around firmware and kind of embedded software. Moved up to here about 20 years ago to work for Microsoft on kind of all things device related, Windows Phone, the Zune music player, all kinds of funky things, a lot of Edge AI, IoT, Azure engineering for IoT. Did that for about 18 years, left in 2023. And I was approached about a year or so ago from a colleague of mine. I was going to say an old colleague. He's not that old, but at Qualcomm. And he's like, well, we have this foundation, this nonprofit that's focused on, at the time it was called the TinyML Foundation. And it was focused on AI in very resource constrained environments. And he's like, we're looking for someone to run this thing and kind of reboot it or kind of take it to the next level. And, I'd already been involved in the tech and I knew the tech and I knew him pretty well. And I thought, oh, this would be cool because it's like, and I'll talk a little more about what we do, but it is a nonprofit and we're very education oriented and empowering people through knowledge and working with tech companies. So I did that, took that over about a little over a year ago, rebranded it the Edge AI Foundation. So we ditched the TinyML name, which kind of made sense. And here we are, so it's exciting.
Yeah, thank you for that. I'm excited. I mentioned before the show as well that I haven't had anyone who has focused in on Edge AI on the show before. So I think there's a lot of topics that we can get into that our audience will love to learn more about. But specifically for you, what was kind of you gave that background on why you joined Edge AI, but was there a moment where you realized Edge AI specifically would have such a large impact in terms of how businesses are deploying intelligence across their operations?
Yeah, I mean, it's there's a lot of good reasons for, and I think, people have thought about running AI workloads in edge devices. Sometimes we don't call them edge. Sometimes they're IoT devices. Sometimes they're embedded devices, but and it's been around a little while. I mean, as you know, AI itself has been around the term has been around since I think 1957. So it's been around a while, and it wasn't until kind of cloud systems could kind of acquire enough data and horsepower to actually do something with these models where it made sense. But at the same time, people were thinking about running AI workloads in these edge devices and like in cameras and things like that, where you could do, image recognition, facial recognition, people counting, all kinds of stuff like that. That started to happen maybe like 10 years ago, 5 to 10 years ago. So people kind of saw, they said, well, chips are going to get faster, models are going to get more efficient, and so it's inevitable that this is just going to become a thing. The idea is you want to, bring AI to your data. You don't want to send your data to the AI, right? So you want to run AI workloads as close to where the data is created as possible. That's the maximum efficiency, lowest cost, maximum impact. And the only thing that's been keeping folks from doing that primarily is the performance, and capabilities of edge devices, which in the past few years have really been growing by leaps and bounds, right? What you can do now, you can run generative AI models, multi-billion point models on the edge. You can run agentic AI on the edge. You can run vision AI on the edge. You can audio. I mean, it's all happening. If you look at what Apple announced recently with the Apple Watch and the AirPods, great examples of lots of kind of on-device or edge AI that's happening where the data is created. So for me, it was sort of like being in this space for a long time. It was sort of inevitable, and a lot of times we look at technology and we know what's inevitable. We just don't know when it's going to happen. And so that's the hard part, but now it's happening. And so I think we're seeing a real explosion of development and deployment with edge AI as a much more efficient and effective solution than sending a bunch of data to the cloud and then sending it back and blah, 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 blah. So that to me was like, it was, once I started to see what was actually happening, it was pretty obvious.
Yeah, I think it's interesting that you mentioned Apple right on the top there, because they're so routinely the company that comes up as someone, given that context is king, particularly in like so many of these use cases that we're seeing on the consumer side. And all that context lives on your device, like all that data is on your device. It's such a natural place to be running all of this. And of course, like so much more secure to be running it on device than, as you said, to be like sending all of this stuff into the cloud. I think it is a very exciting time because, I think Apple has been a little bit slow, many people would say, as far as like how they've gotten their foot in the race, but they do have an immense potential. And I think much more broadly to your point, right? Like edge AI, a lot of different factors have converged to make this like a very strong potential impact now. What kind of convinced you to leave? What was the tipping point for you to leave the corporate world and like go into the nonprofit and then really like, the time is now?
Yeah, I mean, I've had kind of like 3 phases in my career. I did a lot of startup work. I mentioned in the Bay Area, Silicon Valley. I actually started in Boston as a BIOS engineer for a small firmware company called Phoenix Technologies. It's kind of part of ancient PC history. And I really liked that. I did, the startup thing. I had a startup in the Bay Area, worked at a 50-person company, 75-person company, did that stuff. And then switched to Microsoft, which was like working in a, 200,000 person company and, big scale and process. And, once you get that oil tanker pointed in a certain direction, you can do a lot of damage. And so that was great. But now it feels like this area, and I've been doing nonprofit work, when I was at Microsoft doing some volunteer work in the community. And I thought wouldn't be cool to sort of combine the tech with something that was a little more beneficial for society, let's say, in terms of education and understanding. And so for me, this is a really great way to combine, startup and big, because we do work with a lot of big tech. We're 100% underwritten by tech companies. Some of them are quite large. And so working with big tech is great, but also I get to work with startups and I get to run the company, and we get to sort of chart our own path in this AI space, which, as just Apple announcements yesterday, every week there's another announcement or breakthrough or whatever, whether it's DeepSeek or Apple or OpenAI running their own learning platform or whatever. Every week there's something new. So that kind of keeps things moving.
Yeah, it's a space that having a podcast in can be frustrating because when you have an episode backlog, things date very fast. But
that's right. Yes.
It is
now this is like old school.
It does make it an interesting one. And having focused on education specifically, what do you see as some of the biggest misconceptions that you're finding about edge AI when it comes to the communities that you work with?
Well, I mean, there's always the question, what is edge AI? So, the term is kind of nebulous on purpose. I would call it inclusive on purpose. You can get into like, well, how many, is it milliwatts or watts, or is it this many tops, or, what's the borderline? Those become exclusive conversations where you start excluding things, and especially excluding innovation, which you don't want to do. So edge AI is an inclusive term that really talks about any time you're running AI, I would say outside of multi-tenant data centers. So cloud AI, if you're running ChatGPT and stuff, that's running in a multi-tenant data center like Azure or AWS or GCP, which is cool. Just attach your nuclear power plant to it and you're all good. But edge AI is running, on things in the real world. Our tagline is connecting AI to the real world. And so, a lot of people are like, well, what is it? Okay, now I get it. And now, how capable is it? Like, what are some of the scenarios that are possible with edge AI? Because a lot of times people don't, it moves very quickly, the tech, and they're not quite sure exactly how much can be done on the edge. And it turns out a lot. And so depending on whether you're in agriculture or, public water systems or security and safety or healthcare, pretty much many of these scenarios can be done at the edge where the data is created. And I think that's the big aha moment for a lot of folks. If you're working at a Fortune 500, if you're working at a consumer product company or a hospitality or cruise line or Disneyland, I don't care, whatever, and you're thinking about how do I incorporate this stuff into my processes, you'd probably be surprised at how capable it is and what it can do.
And do you see this as a battle between edge AI providers or cloud native vendors? Is it, are you always coming up against that in terms of a decision to be made about how to deploy this? Or like, what is that dynamic like?
Yeah, I mean, it's not edge versus cloud. It really is edge plus cloud, because the cloud is super useful in lots of areas, and time series insights and data lake analysis and a lot of that stuff, and the training, of course. If you're talking about model training, at least the core training really needs to happen on these high performance platforms in the cloud. So, and pretty much every deployment that's out there is going to get connected to the cloud at some point for some reason, whether it's, maintenance and security and telemetry and things like that too. So it's not an either or. It's really like, how do these things work together and where's the right place to run the workloads? And that's usually an architectural decision when someone's thinking about, okay, I'm deploying these pizza ovens to like 6,000 pizza places around the US, and I want the ovens to be able to do X, Y, and Z and stuff. Where should I run that AI workload? Okay. Probably at the oven, right? Don't send your sensor data to the cloud and wait for it to come back. So these are like architectural decisions that everyone is kind of going through. If you're a farmer, you're working in agriculture, all these things require like an analysis of the solution, but it's usually running the right workload at the right place. And in fact, there are multiple edges and multiple hops along the way between edge and cloud, right? So like in a parking garage, you could have really simple, you've probably seen this, whether spaces are available or not available. You have like little lights that show red and green and stuff. And you're doing, a lot of kind of anomaly detection and things in the garage itself, and you're counting cars, and it's pretty simple machine learning stuff. You also could be doing some license plate recognition or car model recognition or other things like that. But you could also then, say, oh, well, I did a license plate recognition, but, the result was kind of fuzzy. I don't really know what it is. You could kick that model up to the cloud and say, actually run it up here and give me some corroboration. And so when you're seeing these different workloads stitched together, and you're using the cloud when appropriate and the edge when appropriate, that's really when you get successful deployments.
Yeah, that's great. I love that example of, what's on the edge, what's happening in terms of triage, where does it go? Like, what are those triggers? Those examples are really helpful, I think, for people that are trying to understand what this is. Can you provide a few more examples and then maybe just break it down with that kind of framework of like, how do you decide which workload runs where, and what are some examples of when it might kickstart something going to the cloud?
Well, I'm probably a little biased, but I would say if you can run the workload, if you run the AI workload where the data is created, do that. Like, don't
Good
add
first principle.
First principle, don't add a cloud tax to your deployment if you can avoid it, because then you're going to pay for the ingress, you're going to pay for the egress, you're going to pay for the connectivity, you're going to pay for latency. And, I love Microsoft. I'm still a shareholder, but they don't need to make any more money on extra cloud services. So I would say the first principles is if you can run the AI where the thing is happening, then do that. If you need to kick it up to the cloud, like I said, for like time series insights or more complex, analysis, then do that too. And it's like, one really hot area for edge AI is agriculture. So you've probably seen videos. I mean, the amount of tech going into ag these days, for identification of, not only moisture content and health of plants and, weed detection, as well as obviously like physical AI to properly, harvest crops and things like that. I mean, it's pervasive, and that's all happening at the farm. Like there's not a lot of cloud stuff going on. There's probably some cloud analysis of like your whole operation and all that stuff, which is cool. But the stuff that's happening in the real world is happening like in the equipment. And what's cool about agriculture and a lot of the edge AI that's happening in agriculture, it's applicable not only for the John Deere giant ag stuff, but it's for local farms. Think about how do you in a smaller farm environment, and we're not in the US anymore. Let's say we're in the developing South, right? We want higher yields using less water and less energy. A lot of this tech is actually quite affordable. So edge AI, if you don't require a cloud, can be, a Raspberry Pi device or something inexpensive, could be solar powered, can give you lots of insights and information as to what's happening in your space. So the other benefit of edge AI is the lower cost enables it to be much more democratized, right? So that anyone, any farmer or anyone trying to get clean water or whatever can use this technology. You don't need to be a Fortune 100 agriculture company. You don't have to be like Philip Morris or whatever. I don't know. Do they still make cigarettes or whatever? So, that's the other thing about edge AI. It's very democratized and can be very low cost.
Yeah, it's an interesting thing. I don't think we talk about enough. There's so much attention is paid to the large model providers, the large model gardens today in generative, and the aggregation and centralization of all of that use data and, the battle for inference, like all of those things. But it's, I think, a powerful idea that there is so much value, so many use cases, so much adoption of this technology, and this completely parallel, and not completely parallel, because I know that it can be connected, but that there is this other path that we often don't think about. And you mentioned agriculture. Are there any other industries that you feel are kind of secretly leading this adoption that people that overemphasize what's going on with big tech aren't paying attention to?
I mean, if you've probably gone through a drive-through restaurant lately, Taco Bell or whatever, McDonald's. I mean, there's a ton of tech happening in drive-through, in hospitality, in restaurants, food services. I mean, for better or worse, a lot of those businesses are trying to minimize their labor costs. Let me put it that way, right? So how do you really highly automate drive-through restaurants for food prep and food service? I mean, we've seen scenarios where, you use a camera to detect whether the right hamburger goes in the right bag. Did you ever go through a drive-through and they give you a bag and it's the wrong bag?
Yeah.
Right. That's a disaster, because not only are you pissed off, someone else is pissed off too, because they got the wrong bag too. So, using AI vision to make sure you're putting the right hamburger in the right bag, making sure you're cooking your fries, on time, not too many too fast, and not having to wait. So there's a lot of tech and a lot of AI stuff happening in these kind of quick serve restaurants. They call them quick serve QSRs. So that's another one that probably people are encountering it every day. They don't even realize it. And then, that technology is applicable to, manufacturing environments, industrial environments. At some point you'll see I was in Boston the other day doing the rental car shuttle. You land and you get on that shuttle, which everyone hates. Because you fly a long time and then you have to get on this shuttle and go through traffic. But that's going to be like an autonomous vehicle pretty soon, right? You can't imagine that someone's going to be driving that fixed route shuttle all the time. There'll probably be like an Avis ambassador on the bus helping you with your luggage and stuff. But the vehicle itself will become autonomous and and drive on its own. And that's another example where if people use full self-driving on their Teslas and stuff, that's another example of edge AI that's happening on a daily basis.
I love the drive-through example, if only because there have been so many headlines about, the Taco Bell order where the guy broke the system by ordering 18,000 tacos or something, or like some order gone horrendously wrong. And it's like everyone is piling on to point out the limits of AI, but then they're not thinking about the 9,000 other use cases that are actively working in the background at the same place. So it's funny to see just like how widespread some of that adoption is. I think if you're not in a specific industry working in that environment, you would almost have no idea. Like you have to be willing to peel back the layers a little bit to understand what's happening.
Yeah. I saw a deployment once. I won't confidentiality, but there was a system that could count cars in the parking lot of a quick serve restaurant. And then based on that, figure out how many, there's a way to figure out how many fries are going to be consumed based on how many cars come in the parking lot, because you just know. And so it was like an automated fryolator that would make fries on demand based on the cars counted in the parking lot. And so you always had hot, fresh fries all the time, totally driven through AI. And so, it makes sense. I mean, I guess it's not good if you make fries for a living. That's you're going to need to move to fix the ice cream machine or something. But someone has to do it.
Yeah. And what's kind of the most surprising use cases that you've seen across all of your work? And I mean, you work in so many industries, maybe focus one that you've seen drive a lot of business value, and then maybe one that you've seen has, solved a particular humanitarian or environmental challenge.
Yeah. Well, first of all, like as I mentioned, I love seeing deployment of edge AI in local communities, especially in the developing South. So we underwrite a bunch of educational programs in the developing South for edge AI and TinyML, where we teach teachers how to do this stuff, and we get a lot of hardware donated, and so that people can learn how to program and develop their own edge AI solutions locally for not a lot of money. So I think that in general is a trend that's going to continue. Like I said, it's democratized, it's low cost, it's low power. One of the cool ones I saw recently was, if you're familiar with this term called deep brain stimulation, or deep DBS. And for people with Parkinson's or other conditions, you can put probes in the brain to do electrical impulses to help mitigate tremors and other issues. And it can be pretty effective. But it's pretty invasive, obviously. And it's kind of open-ended. Like you basically set it up and it either works or it doesn't. And if it doesn't work, you have to like tune it and see if that helps. And it's very difficult to sort of get it to work right. But we saw a company developing basically an implant that would be able to measure the electrical signals and the response of the brain and tune itself to be effective as a deep brain stimulation technique without external wires and without people futzing with knobs and stuff like that. So it was almost like a self-learning DBS system, so that, you could get your Parkinson's under control and things like that, which is incredible. I mean, imagine if, that you go in for that treatment and get that implant and then you're good. And it's like basically, self-powered or powered for decades, basically, because it's super low power. And it's able to monitor the brain and adjust the signals to help you. And so I thought that was, that's something that obviously can hit home for a lot of people and be very, very impactful. So.
And in terms of, you mentioned towards the beginning of our conversation, some of the trade-offs between edge AI, or like the triage between edge AI going to the cloud. Mm-hmm. The biggest misconception being essentially just lack of awareness of what edge AI can do and what's possible. Are there any other major misconceptions that you're seeing among enterprises or any of the organizations that you work with?
Well, I mean, I think the challenge is always, I think the IoT wave that we had for a while there was pretty rough. So if a lot of people have Alexas, I mean, I will jokingly say that the Amazon Alexa was the single worst thing to ever happen to IoT ever, because everyone got one and it doesn't work and everyone's pissed off at it. And so it created like a whole, I would say generation of skeptics that any of this stuff works. So the stuff works a lot better now than it used to, but, people are concerned about deploying equipment and hardware and how do I update it and how do I keep it secure and, complexity, people fear complexity. And, so we're trying to do a lot of the foundation on education and collaboration and working groups to help people work together to take all the friction out of that. So what are the different friction points in these deployments and developments that, we could take out of it so that if you do say, yeah, I want to instrument my pizza ovens and make them like more AI responsive, then, it's not that complicated. It should be just like Lego bricks that you just plug together and, you don't need 12 PhDs to like figure it out. Right. So I think there's a fear of complexity, but that's working itself out. There's a lot of companies out there putting solutions together that are very repeatable, very, easily to support. They plug into your existing, IT infrastructure. The OT side plugs into the IT side nicely. It's all managed through, Azure and AWS as well. So it plays nice with the cloud. So I think a lot of that stuff's being worked out or has been worked out, but we had that wave of IoT where everyone went really early and deployed a bunch of crazy stuff and it didn't really work very well and everyone got burned on it. And, like I said, if I could go back in time and recall the Alexa and it never existed, I think we'd be in a lot better shape right now. But like, how many times have you said, you outfit Alexa with your house and to turn lights on and off. And then, you hear your significant other like screaming at the Alexa to like turn the lights on and it's not understanding you. It's terrible. So hopefully we're past that now, but I don't know.
I have been that partner where I almost refuse to stop talking to it. Not an Alexa, but a different provider with a similar device. And it's equally frustrating. And how do you talk people through when they're making these decisions between edge plus cloud? What happens where? Like, how do they think about the trade-offs between what might be varying levels of model accuracy and the constraints that are operating on a device? Are there any simple ways to help people navigate those decisions?
Okay, so first is you want to kind of be clear on your outcomes. So, what are the outcomes that you want out of this particular deployment? Right. Is it reducing cost or improving yield or whatever? So getting super clear on that. Then you can look at what are your constraints around cost, power, does this have to be deployed in a rugged environment or not? That starts to sort of then put some boundaries around the solution. And then you can determine, okay, so given that, how much of this can I get done where the data is created? Are there platforms out there that have the horsepower in the right cost profile and thermal profile to get it done? Then assuming that's the case, then it's around deployment and managing it and orchestrating it. So it really drives from those outcomes and then, figuring out what your constraints are for deployment. And we had, going back to the pizza example, one of the things people don't realize when you put tech equipment in a pizza kitchen. So when you put tech equipment in a pizza kitchen, they have to be fanless. And the reason why you can't have a fan is because it will suck in all the flour that's floating in the air and gum up your machines, which I didn't realize until this customer said, yeah, that's a problem. So, okay, now we need a fanless solution. Okay, so that's like, maybe a different chip and different platform. And, if that's a restraint or constraint, you just have to deal with it.
That's a great example because it's one of those things where you would never think about that unless you were the one operating the system or like you understood the dynamics of that particular environment so well.
Yeah, and I don't think they realized it either until they started doing some pilots and they're like, why are these machines shutting off? It's like, and they open it up and it's like, ugh, it's filled with flour. So,
Yeah, it's just the reality of operating at the edge, right? Like, what are those environmental variables that you don't have to think about in the cloud?
Or like in the energy sector, there's some people have probably heard of like IP68 and these different types of like ruggedized standards. There's another level way above that where, the devices are not allowed to create a spark in case they get crushed. So in the refinery environment and stuff, you can't create any sparks. And so you have to create equipment that is actually kind of encased in epoxy. And that's a whole other level of, requirement that you have. So, okay. So that's a physical requirement because of the environmental factors. And then you have to think about what are the platforms that can run in that environment? Who's willing to build these devices, encased in epoxy? Like the PCB is in epoxy and then it's in case. So yeah, so little things like that are like, they make the big difference between scale deployments and failed POCs.
Yeah. And when leaders are thinking about potential use cases with edge AI, or maybe even going all in and say, hey, we're going to do an edge first AI strategy, like this is what we're doing, are there questions you highly recommend they ask themselves before they go head first into something like that?
Well, yeah, I mean, I think clearly defining the scenarios up front to make sure that there's horsepower there to take care of it. So like back in the quick serve restaurant example, you've got, okay, I want to make sure the right hamburger goes in the right bag. Maybe I want to measure dwell time, how long people are waiting to give an order. Maybe I want to measure how long does it take for a table to be wiped down after someone leaves it. So you kind of list out all of your scenarios first, and then you figure out, okay, well, how many, what kind of models do I need to use in model architecture? And then, can I actually execute it with the equipment in the right cost thing? So, it's a bit of a multivariate equation, but if you're working with a good solution provider and architect, they can figure that stuff out. Some of the newer things we're seeing is like, how do you use generative AI in the edge combined with kind of sensor information, right? So in one of the scenarios I had heard about was, in a hospital room, if you've had the unfortunate experience of going into someone's hospital room, there's like all these sensors going on, right? Measuring all this stuff. It turns out like generative AI is very good at taking like sensor data, what we call sensor fusion data, and actually making sense of it, and actually explaining what's going on. So imagine you walked into a hospital room, and even as a visitor, and say, how's my friend doing, and the generative AI could explain what's going on, with all the sensor data that's in there, or if you're a nurse or a doctor. And so any of those situations where you have lots of sensor data, you could use generative AI to sort of make a coherent summary of what's going on in those scenarios. So I think that's pretty cool combination of kind of AI.
Yeah, that is very cool. I would hope that there are some guardrails around the hallucinations that might happen and some of the, I guess, the bedside manner. But yeah, we're getting there.
Yeah.
Yeah.
And also, like, that's a great example where you'd want to keep the data secure and private, and maybe that's not
Right.
cloud data. It's
Yeah.
happening locally, right? Or maybe another scenario is you've got a piece of equipment that has lots of data, sensors on it about how it's performing. And what if you could go up and just ask that equipment, how are you doing? And it could say, you know what, I need this changed. Make sure you change out this soon because it's going to fail or whatever. Like you could actually, talk to your car engine and like understand the maintenance that's required on it. Because it's aggregating all of this information and communicating that to you. So, a little freaky, but good use of combining AI models together on the edge.
Yeah, I really love that example because it's such a good, well, one, I'm a sci-fi nerd, so that feels like we're somewhat in the future of things that happen in sci-fi. But even more so, so many of the use cases that I hear CIOs on this show in particular talk about that are driving a ton of value, just like in terms of bottom line for large businesses, is predictive analytics around like equipment malfunction and manufacturing and health diagnostics and whatever it might be. Usually when I'm thinking about that use case, I'm thinking about, okay, they're like aggregating all of this data and someone is like, there's certain triggers that might send someone to go replace or like do maintenance on some device, but like enabling the operator on the ground to just like have that very naturally. And just thinking about all the different use cases that actually opens up is very interesting. I'd never thought about that. Thanks for sharing it. Are there any?
Well, yeah.
Go ahead.
Well, I was going to say, I mean, what you could do is you trigger like an agentic AI workload off of some of those signals, right? So
Mm-hmm.
you have sort of an agentic, floor manager working 24/7. And instead of just showing a dashboard of data and dials and stuff, it's actually that data is kicking off some agentic process where they are, maybe proactively doing some things, right?
Yeah.
To fix problems, or, you know, giving you the morning summary of like, okay, here's everything that happened last night, and here's some stuff you need to be aware of. And those are really, I think, could be very powerful kind of agentic AI scenarios that are using edge processing.
Mm-hmm. Yeah, that's a very, very good example. Are there any other implementations that you think solved a problem that seemed impossible or that no one was thinking about at all?
One of the things we've seen is like around, and we've done a couple of shows on this on our YouTube channel around pedestrian safety. And turns out that there's one of the challenges with deployment of AI sensors in cities and municipalities is cost. And so if you think about traditional, cameras and things like that are powered, you have to tear up the sidewalks to connect them and to power them and stuff. But what if you had like a solar powered lightweight camera that could be kind of strapped to a pole and connected wirelessly and could detect if people are heading toward the roadway, in a dangerous way, and could trigger a set of lights or some other warnings to prevent pedestrian injury. And, that's been done. It's actually like the city of San Jose and some other places have done that, where they've deployed these very lightweight solar powered pedestrian safety cameras. We had one story from a city in Colorado that was unfortunately having a big kind of methamphetamine issue. And there was this one particular roadway where they had like motels on one side of the roadway and like liquor stores or something on the other side. And it was a problem. And there was a number of fatalities that were happening there. And what they did was they implemented a system like this to warn drivers, to warn the driver that someone is crossing the road at night, so that the driver could slow down. Because obviously the person being injured is terrible, but also the person that hits the person is traumatized. So they implemented this solution, and they radically brought down, deaths and injuries from people crossing the road in an unsafe way. But you couldn't do that unless you had, edge AI processing, low power, easy to deploy, low cost to deploy solutions. So I think we're going to see more of that out there where, the barriers to deploy these things is much, much lower, orders of magnitude less expensive than it used to be. So,
And assuming that trajectory keeps going forward, right, and we see millions, billions of these devices come online, right? How can we think about a world of AI governance, model updates, like managing that complexity, like you put it, when there's all these devices out there? Like, how do you deal with some of that?
yeah, I mean, there's some good, principles around safety and security and trustless edge and things that a lot of people are driving. And there's a lot of best practices out there. I mean, obviously it depends on the solution providers and the people paying for the deployments to make sure that they abide by those best practices, but there's no shortage of them out there. A lot of these things roll up into cloud connectivity ultimately and can be managed from the cloud and should be. And in fact, what we're seeing a lot of companies that are basically, when you deploy workloads on the cloud, you do it in a very standardized way with containers and Kubernetes and things like that. And that people are using those same kind of techniques to manage edge devices and edge AI workloads. So it turns out like the edge equipment and the cameras and things just look like resources in the cloud and can be managed just like virtual workloads in the cloud. So people are extending the kind of CNCF Kubernetes type stuff all the way out to the lightest edge equipment, including AI model deployment and management. So you're using sort of cloud first or cloud native management tools and techniques to manage these heterogeneous edge pieces. So if you think about it like that, then it makes sense. Then you can actually manage these things as just a set of resources. Some of them are in the physical world, some are in the virtual world. But it's all managed as a single system. And so you avoid the old IoT days of the kind of the one-off, weird updating and multiple dashboards and all that other stuff.
Yeah, that is, I can imagine, a relatively large unlock for the organizations trying to figure this stuff out at scale, like just that mindset shift. Yeah. Okay. I mean, we're coming up on time, so I want to ask some quick fire questions that are relatively large questions I'm going to force you into relatively short answers.
One word answers.
Yeah. But if you're saying, edge or cloud for real-time AI inference in 2030, which one are you picking?
Definitely start with the edge.
Okay. Definitely. And what's the biggest edge?
I would say now you should start with the edge. Like, again, it's like you start with the edge, and then if you can't do it on the edge for cost reasons or complexity reasons, then you consider the cloud. That would be my guidance.
That's good. Simple guidance is the best guidance, in my opinion. What's the biggest edge AI myth that you feel like needs to die?
That it's too complicated. Sure, it is somewhat complicated, but it's definitely feasible, and there's lots of expertise out there to get the solutions to market. So I think the days of bare metal one-off deployments are over, and we're now in a much more kind of cloud native standardized approach to edge.
And if there's one metric that every AI leader within, deploying these things should be tracking, I know we're talking about millions of potential use cases. Is there one metric you think they should be tracking for edge deployments?
I think your metrics for success are going to be based on what your outcomes are, for your deployment. So you really need to measure against that. If that's like, customer satisfaction or labor costs or yield or whatever. So I think for that's important. For us in the Edge AI Foundation, we're always interested in, deployments and like what's the percentage of deployments that start on the edge as opposed to start on the cloud. We're looking at the growth numbers of the market, and it's supposed to reach about 80 billion annually by 2030 or something like that. So it's like, we're looking at CAGR and, overall like kind of market growth as metrics. Yeah.
That's great. And is some of that research available? This is kind of my last question for people that want to learn more about Edge AI, follow your work, potentially look at some of this research. Where should they go?
Yeah. So I would say a couple of things. You can subscribe to our YouTube channel. So Edge AI Foundation up there. We have something every week, new content every week, expert talks and other things talking about the technology in the market and what's new, what's happening, and sample deployments. We have a lot of example stories on deployments too. So YouTube channel is great. Our website, edgeaifoundation.org. Lots of white papers from our working groups and other back catalog stuff. And we do have events too. We're going to be in Taipei in November for a couple of days, and we were in Austin, Texas last February. We'll be back in the US next year. So yeah, if you go to our website, you'll see all kinds of events. There's also a lot of events happening in the industry in this space. So there's nothing better than kind of going somewhere and seeing the stuff and talking to people about how it works to really kind of grok what's happening in the space. So I encourage people to go to our events page. There's stuff happening around the world all the time, and kind of lean in and get your hands on it and talk to folks about it.
Yeah, well, you heard it from Pete Bernard. Go check out Edge AI Foundation. Pete, thank you so much for your time today. I really, really enjoyed this conversation. I know I learned a lot. I'm sure our audience did too.
Awesome. Thanks for the opportunity.